So in Informatica, we have four kind of partitioning: key range partitioning, pass-through partitioning, round-robin partitioning, and hash partitioning. In hash partitioning, again, we have two ways in which we can use hash partitioning. One is using hash auto keys, and second is using hash user keys. So Informatica Integration Services uses all grouped or sorted ports as compound partition key. For example, we talked about order ID, right?
Mm-hmm.
Let's see, we have order ID, item ID, and customer ID. Okay.
Mm-hmm.
So in case of hash auto keys, we don't want to specify the partitions manually. We'll be using all grouped or sorted ports as compound partition key. We may need to use hash auto keys partitioning at rank, sorter, or unsorted aggregator transformations. So partitioning can be done on transformation level. But this will again be done from session itself. You will not be able to specify this in mapping.
Okay.
So, in aggregator we create groups.
Mm-hmm.
In case of rank partitioning, we create ranks corresponding to given keys. In case of sorter, we sort by specific data. Let's say we want to sort upon by item ID. So we do that in sorter. So in this case, we are gonna be using hash auto keys partitioning. Okay.
Okay.
The second way of using hash partitioning is using hash user keys. It will use a hash function to group rows of data among partitions. So we can define number of ports to generate the partition key. Now that's an internal phenomena how that hash is gonna get generated. So we will simply be choosing that here we want to partition on customer ID. Item ID. No, it is not working properly. So we'll be manually specifying that we want to partition on customer ID, order ID, and item ID. And Informatica will internally generate a hash corresponding to them. It will look something like this, the hash. It will not be transparent to us that how the generated hash looks like, but it will create hash corresponding to unique values of these three attributes on which we choose to group upon. Okay.
Okay.
So that was about hash partitioning. The next is key range partitions. So let's suppose our data looks like this. And so on. Okay.
Mm-hmm.
And so on. So you are analyzing a common pattern over here that all these values are ending in 1. You remember we discussed modulus.
Yes.
So what if we'll do order ID, comma 100. What will this return? 1. This will also return 1.
One.
So this is remainder, or as we call it in Hindi, Sheshfal. Okay. So Mirza, here we will be specifying that we want to use this key from this range to this range only. Okay.
Okay.
So I'll give you another example. So the values of order ID are like this. Let's suppose we want to create 10 partitions. 1 to 100 in first partition, 101 to 200 in second partition, 200 to 300 in third, 201 to 300 in third partition, 301 to 400 in next partition, and so on. We'll be creating 10 partitions like this.
Okay.
So we need to define these partitions at session level itself. What will happen? On session level, we'll click on partitions, we'll click on our force qualifier, and then we will choose to define 10 partitions. And in each partition, we will be modifying the where condition, in which we will be specifying that take the customer IDs which are lesser than 100, which are greater than 100, but lesser than 200, and so on.
Okay.
So this is key range partition. There is one caution when we use key range partition. We ourselves need to take care that all the cases are getting included. Mirza, you know what a pie chart is?
Yes. Mm-hmm.
So let's suppose this is your pie chart. According to your condition, your data was supposed to be divided in this 6 partitions, okay?
Mm-hmm.
So you remembered to mention this, and this, but you missed out on these two. So Informatica will not warn you that you missed out these 2 partitions. It will just go ahead with what information you have provided to Informatica. It will just go ahead with these 4 partitions. Okay?
Okay. Even, even
Let's
though you divided by 6 partition.
so let's suppose we have in earlier example we had order IDs from 1 to 1000. So you remember to define partition from 100 to 200, 200 to 300, 300 to 400, and you forgot to mention rest of them.
Mm-hmm.
So what Informatica will do, it will in those as a result of those partitions only this much data will pass. Rest all
Okay.
will get filtered. So you need to take care of it. You need to design your partition in a manner that all the data is getting included. Okay?
Okay.
You need to take care of it yourself in case of key range partition. Next, pass through partition. So in this case, it means integration service. Who is the doer of each and every action in Informatica? Integration services is responsible for doing all that,
Mhm.
all the actions. So integration services will pass all rows at one partition point to next partition point without redistributing them. If we will choose pass-through partitioning, we'll only do it where we want to create an additional pipeline stage to improve performance, but we do not want to change the distribution of data across partitions.
That
Let's
means like
let's take a
uh,
smaller example.
okay.
I'm gonna give you the example and then everything will be clear. Let's suppose this is your data. Keep it simple. Okay?
Mhm.
And internally, these are the indexes assigned to your data. One, two, three, four, five, six, seven, 8. So you know it very well that this is your data, but this is not how it looks like. It looks like this. 1 on the first place, 3 on the second place, 2 on the third place, 7 on the fourth place, 4 on the fifth place, 8 on the sixth place, then 9, then 10, then 5, and then 6. This is how your data is stored internally. Okay?
Okay. Okay.
These were the indexes which are stored in hexadecimal forms inside databases. So this is how your data is stored in databases. So right now our aim is to just pass all the rows at one partition point to next partition point without redistributing them. That's why we will choose pass-through partition. We want to create an additional pipeline stage to improve performance, but we do not want to change the distribution. So we will say that this is my data. Create randomly 3 partitions corresponding to it. So Informatica will distribute the data in these 3 partitions. This is purely to improve performance. You don't want any control over the data.
Okay.
Next, round robin partitioning. TITIO. In this case, IES will distribute blocks of data to one or more partitions. You know the concept of round robin, Mirza?
Yes, like you can do like whenever you do partitioning, like you have to do like an even number.
No.
No.
So it comes from concept of operating systems. So in operating systems, whenever we talk of resources, we generally divide them in threads available. Let's say at certain point of time, I have 64 threads of processing available with me. So I want to divide my data in 4 parts, assigning 16 threads to each part.
Okay.
So this is what we will be doing in round robin partitioning. Assume a tank with 100 liters of water and these 3 holes at its bottom. So certain amount of water can flow through it, right?
Mm-hmm.
So what we'll be doing, we'll be explicitly specifying that I am allowed to use only this many holes for flowing my data, and rest of the holes will be used for flowing some other data. This many resources I want to use at a time. So, okay. I don't think it is making sense to you right now, but you can Google it online and read more about round robin scheduling. Okay?
Okay.
You need to
No,
study it.
but
Then it will be clear.
like say example, like you have 100 rows of data, like you choose a three pipeline.
Mhm.
So for my understanding, like in round robin, you have to make even number, like 100 rows into three pipeline. That means it's gonna be 33.33, right? Yeah.
So Mirza, it totally depends on what are the resources I'm having in my pocket right now.
Okay.
Based on this, my integration will distribute my blocks of data to one or more partitions. At a point of time, let's say I have more resources, so it will distribute my data into more partitions. So I do not have control here over number of partitions that are going to be created. So we'll use round robin partitioning so that each partition processes rows based on the number and size of the blocks. Okay.
Okay.
Uh, if you are still not clear, we will come back to it later on. Okay.
No, that's fine. But only one question, like
For now, keep these things in mind. What we
okay.
discussed here, especially the range partition. It is very important. We use it very frequently. Yeah, Mirza, you are asking something. Go ahead, please.
Uh, my question, like in real time, like in session level, which property is under which property you do the partitioning? Do you
Will
remember the option?
Yes, I remember it. So on session level, we have this source qualifier mentioned, right?
Uh-huh.
So when while mentioning the sorry while clicking on the source qualifier, it will show us option to create partitions. We'll click on that, then it will show us a map of how our data is flowing. Then we will choose to create partitions over there.
Okay.
Similar will happen in case of sorter, aggregator, rank, and every other transformation on which we can create partitions. So let's discuss how do we set partition types in the pipeline. So we can create different partition types at different points in pipeline. So let's suppose this is our mapping. This is my source. This is my source qualifier. Let's suppose this is a filter. Then let's use another transformation called sorter. Sorter active है या passive है?
So there's a so there's a active
Why?
because it change uh, number of changing row.
Changing number of rows passing through it.
Yes.
True. And how it is doing it? By limiting the number of rows which are coming from source
So
when it is sorting them. Okay. So let's take this example. So let's suppose our source is having the data about items. So this mapping reads data about items and calculates average, let's say average costs and prices. Okay.
Okay.
Let's suppose. So it must read item information from given sources. Let's say my source is indirect and my data is present in multiple slate files. Okay. मिर्जा मैंने आपको इनडायरेक्ट सोर्स का कॉन्सेप्ट बताया हुआ है या नहीं बताया हुआ है तो we'll skip it.
I know that concept.
मल्टीपल स्लेट फाइल्स होती हैं तो हम उन्हें एक कंट्रोल फाइल में मेंशन करते हैं और फिर कंट्रोल फाइल को एज ए सोर्स मेंशन करते हैं.
Yes, and then you can call indirect file by doing the path in the
Okay, fine. You remember, you know it. Great. So this mapping must read item information from given number of flat files, which can be vary in sizes. And then let's say we have discontinued some items, so we'll filter them at this point. Okay.
Okay.
At this point, we'll filter them. And after that, we want to sort the items by item ID, or let's say we want to sort items by their description. Then we will want to aggregate and calculate the average prices and wholesale costs. And then we want to write the results to a relational database target. Okay?
Yeah. Upam, give me a minute, please. Just give me a minute.
Sure, Mirza. So in sorted transformation, in order to eliminate the overlapping groups, as we also need it in aggregated transformation, we'll use hash auto key partitioning at the sorted transformation. So it causes integration services to group all the items with same description into same partition before sorter and aggregated transformation process the rows. तो इसके लिए हमें पहले डिफॉल्ट पार्टीशन पॉइंट डिलीट करना पड़ेगा. एग्रीगेटर ट्रांसफॉर्मेशन में एक डिफॉल्ट पार्टीशनिंग पॉइंट होता है, वो हमें डिलीट करना पड़ेगा. बट ये बहुत ज्यादा डिटेल में हो गया तो यू डोंट नीड टू रिमेम्बर इट. आई एम जस्ट मेकिंग यू फेमिलियर विद एवरीथिंग.
Basically, if I can at the
you can remember if you can remember range. If you can remember range partition and pass through partition, that would be enough. Okay.
Key range, right? Yes.
Yeah.
Okay. No, I want to just concentrate clear, like we can do partitioning at a session level or transformation by transformation, but
we will be doing everything on session level itself. ये सब भी हम session level पर ही कर रहे हैं. मैपिंग में ये ऑप्शन नहीं होता.
Yes, but we in like most of the time we do the partitioning in the source qualifier itself, right?
हाँ, हम सिर्फ यहीं पे पार्टीशन करते हैं most of the time. कहाँ गया मेरा पेन?
Yes.
Here. हम सिर्फ सोर्स क्वालिफायर लेवल पे पार्टीशनिंग कर देते हैं. उससे क्या होता है, हमारा डेटा डिवाइड हो गया. Now it will go in different pipes. तो यहीं पे हमारा पर्पस सॉल्व हो जाता है.
Okay.
This is most recommended and mostly used.
Okay, I got it.
Or target, since target is database, all the target tables are partitioned by key range itself. So we'll specify the key range partitioning itself before writing the data into targets. Okay.
Okay. Can you tell me one more time about the target level partition?
Sure. हमने पहले मेंशन किया कि our target is a relational database. Okay. What is happening? Relational.
Oh,
So
Upam, I'm sorry, it's too late. You have to go to the bed, actually.
yeah, actually I do need to, but it's okay. Let's finish this topic.
Yeah, yeah.
So our target is a relational DB. All the tables are partitioned by key range. So in this case, मैंने आपको pie chart दिखाया था.
Yes.
So don't ever forget to include everything in that. कहाँ गया वो? ये रहा. ऐसा केस नहीं होना चाहिए कभी भी that we are forgetting some data.
Okay.
केयरफुली डिफाइन करेंगे कि सब कुछ की रेंज में आ रहा है या नहीं.
Okay.
Now workflow manager sets a default partition type for each partition point in the pipeline. It specifies pass through partition as default partition क्योंकि उसे डेटाबेस लेवल से सिर्फ रीड करना है और इक्वली डिवाइड करना है.
Yes.
इसको ओवरराइड करने के लिए हम क्या करते हैं? पर्टिकुलर ट्रांसफॉर्मेशन पे जाते हैं और वहां पे चेंज करते हैं डिफॉल्ट टाइप को. फॉर एग्जाम्पल फोर्स क्वालिफायर और टारगेट इंस्टेंस पे वर्कफ्लो मैनेजर ने स्पेसिफाई किया था पास थ्रू पार्टीशन. जैसे रैंक और अनसॉर्टेड एग्रीगेटर ट्रांसफॉर्मेशन में भी यही डिफाइन किया हुआ था. बट हम वहां पर गए और हमने पास थ्रू पार्टीशन को चेंज करके की रेंज पार्टीशन किया. So it's a
Okay.
common practice to specify pass-through partitioning for all the transformations which are downstream from a transaction generator. Or it is an active
Okay.
force which generates commits or rollbacks, and upstream. And in case of upstream from a target or a transformation with transaction transformation scope, we'll be specifying this pass-through partitioning only. अब
Okay.
एक केस होता है सेशन लेवल पे कांस्टेंट बेस लोडिंग. क्या होता है ये मिर्जा? थोड़ा बताओगे इसके बारे में?
Oh, constants jabo like a
जब
constants with
प्राइमरी की फॉरेन के रिलेशनशिप
primary
होते हैं तो
key.
इट इज ऑलवेज
Yes.
नेसेसरी
Foreign
टू
key
लोड द
relationship.
टेबल विद प्राइमरी की फर्स्ट एंड फॉरेन की लेटर ऑन.
Yes.
ओके.
Yes.
So if workflow recovery is enabled, the workflow manager sets the partition type to pass through unless the partition point is either an aggregator transformation or rank transformation. Uh,
Okay.
One moment. So if we configure a session to use constraint-based loading, we must specify pass-through partition for all the transformation which are downstream from last active source. That's a constraint. Write it down. ये पूछ सकते हैं आपसे. हम जब उन्हें पार्टीशनिंग एक्सप्लेन करेंगे तो वो पूछेंगे कि अगर हम कांस्टेंट बेस्ड लोडिंग करें तो उस केस में क्या करें. तो इन दैट केस वी मस्ट आई एम डिक्टेटिंग इट, कुड यू प्लीज राइट इट डाउन. We must specify pass-through partitioning for all we must specify pass-through partitioning for all transformations that are downstream from the last active source. Done?
No, not yet.
I will repeat. If we configure the session to use constant-based loading, we must specify pass-through partitioning for all the transformations which are downstream from the last active source.
Okay. I'm sorry. One more time.
Yes. We must specify pass-through partitioning for all transformations that are downstream from the last active source in case of constraint-based loading.
Okay. Okay, Upam, please go to bed. I will talk with you tomorrow.
Okay, fine. Okay. Just write down few
Okay,
exceptions where
yeah.
we cannot use
Uh,
partitions. This is important. Write down few
okay.
transformations in which we cannot use partitioning. Source definition, sequence generator,
Uh-huh.
XML transformation, XML parser, and XML target as well, and all the unconnected transformations. In these kind of transformations, we cannot specify the partitioning.
Partition.
Okay, Mirva, this concludes our topic. We were able to
Okay.
complete it. So read it out, and if you have any questions, drop me email. I will try to answer them.
Okay.